My name is Jason Bond. I'm a plant pathologist here at Southern Illinois University, and the name of our project is using multispectral systems to manage soybean cyst nematode. One of the things that we've been working on for a number of years with this project is to develop a toolkit that will assist farmers in determining the real-time stress of soybean cyst nematode in their fields. It's been a long practice in managing cyst nematode to sample the fields, and that's still something that is recommended at least once every 3 or 4 years to get an update on the level of cyst nematode in those fields. So you can sample at the beginning of the year or at the end of the year. The uniqueness of this project is using some of those same techniques, but also using remote sensing to tell us more about the plant stress and real-time infestation levels of soybean cyst nematodes in their fields. One of the main benefits is when we take soil samples, generally it's going to be at a time when we're out of the season, or maybe we're just starting the season. And so you're pretty far removed from making decisions to manage the organism in that field. So a lot of the constraints that farmers have in their fields, they can make a decision in the season to do something about it. And we lack that with soybean cyst nematode. And sometimes a soil sample that might have been taken, let's say in 2020, as we get ready to prepare planting for 2023, that's a big gap between what the populations were then and maybe the decisions that we're going to be making now. The other thing that's been going on throughout the country is that we have more and more counties that are being infested by this nematode. So probably in excess of 80% of the fields are infested in the state of Illinois with this nematode. So they are increasing in numbers, not only in a geographical sense, but also within a field there's more and more numbers in those fields. The other thing that's going on is we have these populations are even more virulent today than they were even 5 years ago. So our resistant varieties that we're planting today is not enough. They are failing in terms of being able to adequately manage the nematodes by that single process. So we need multiple ways to manage this organism. We need multiple tools like this remote sensing capability to real-time tell us the level of infestation. And not to say it's going to replace soil sampling, but it would be another tool to go along with the soil sampling to enable farmers to better manage their fields.
My name is Ruopu Li, so I'm associate professor in geography and environmental resources at Southern Illinois University at Carbondale. So my research focuses on geospatial technologies for understanding food, energy, and water systems. So this is a project with geography, collaborate with plant pathology and to figure out how we can leverage the multispectral drones to understand the nematode activities in the production field. So our research idea is we can use the drones to take many snapshots over the different plant periods and to understand how the plant may respond to differential infestation level of nematodes. So essentially my research group is responsible for collecting the drone images in the field and processing those images and then do the data analysis. So our methods include image analysis and so the geospatial analysis and also statistical analysis plus the artificial intelligence. So finally, we want to associate the drone image with the variable infestation level of the nematodes.
So we've had 2 good flight years with data.